All right, guys, so I want to go ahead and have you guys start with exploration number 1. Okay, so go ahead and start with exploration number 1. I'm going to push you guys a little bit today with the explorations, okay? We have not done linear inequalities, but I want to see how many connections you can make between doing these simple inequalities that we've done in the past to these inequalities that we have here. So you should know how to write the equation of the boundary line, okay? That's just like we were writing the equation for a regular equation with an equal sign in it, okay? So I'm going to give you guys some time to work through exploration 1, and then we'll kind of come together and talk about it. Go ahead. All right, conversations have kind of died down a little bit. I think we might have hit our stopping point. So I want to write an equation represented by the dashed line, right? So if I am looking at this dashed line, I need to be able to pull out the important pieces of information. So if I am trying to write an equation, I need a slope, and it looks like it also gives me a y-intercept, so that'll be nice. So what is my slope here? Yeah, it's just 1 over 1, right? It's up 1 over 1, so I'm going to say m is 1. Okay, and then my b looks like I'm down 3, right? So my b is going to be negative 3. So I have y equals, oh wait, I know m, 1x minus 3, right? Except I'm not going to use an equal sign, okay? So it says write an equation, so I use an equal sign there. But down in C, do you see that it says write an inequality represented by the graph? Okay? So let's think about this. I want to make some connections between what we know and what we don't know, okay? So just look at the board at this point. You don't have to write all this stuff down. So we have 2 different graphs. Let's do x is less than 5, and let's do x is greater than or equal to 5. Okay, how would I graph the top one? If I have 5 here in the middle, how would I graph the top one? X is less than 5. What kind of dot is it going to be? Open dot. And what does an open dot mean? What does x is less than 5 mean? What does that really mean? Think about the values I'm allowed to take. On x is less than 5, am I allowed to take the value of 5? No, I'm not, right? That's why we place the open dot there. So with x is less than 5, that's telling me I'm not allowed to take the value of 5. I'm allowed to take the value of 4.9999999, right? But I'm not allowed to take the value of 5. That's what the open dot represents. And then less values are back this way. Okay? So an open dot is the equivalent on a linear inequality as a dashed line. Okay? So if I ever have a dashed line, that's the equivalent of an open dot. Okay, the dashed line is what tells me I'm not allowed to take those values. So the same inequality signs that gave us open dots are going to be the same inequality signs that give us dashed lines. Okay, and then when we move to the second inequality, x is greater than or equal to 5. Now, oops, I still have my marker, my eraser. Now that's when I get the solid dot, right? On this second inequality, am I allowed to take the value of 5? On x is greater than or equal to 5, am I allowed to take the value of 5? Yeah, the equal to part tells me that, and then I shade bigger. Right? That's going to be the equivalent of a solid line because it's telling me I'm allowed to take those ordered pairs on that line. Okay? All right, so if I pull back over here, let's see if I can get rid of this. Okay. If I pull back over here to my worksheet, okay, I see that it is a dotted line. Okay, so I'm going to use the same exact terms in my inequality that I did in my equation. So let's go ahead and copy that down. So I have a y, I'm going to have some kind of sign in there, and then I have 1x minus 3. So let's get our inequality sign in there, okay? So what does a dotted line tell you? Does a dotted line tell you it's equal to or not? Not. So it's not going to have an equal to part to it. And then the most simple way to determine what if it's less than or greater than is to look at the shading. Okay? The greater values on a graph are up above. The lesser values on a graph are down below. Okay? So where is my graph shaded? Above or below that line? Below, right? The shaded region is below the line. So below the line would give me a less than sign. And we already said it's not equal to, right? So that's that. So I pull out my slope and my y-intercept just like I would on the other graphs. Okay, I graph the lines the same exact way. It's just there's going to be either a dotted or a solid line, and there's going to be a shaded region based on the inequality sign that's given. Okay? All right, so arming yourself with that information, I want you to try exploration 3 down at the bottom of the page. Okay, so you're going to try to graph these inequalities, these linear inequalities. So you graph the boundary line exactly the same way you would an equation, except then you have a decision to make. You have two decisions to make. You have to decide, is it going to be a dotted boundary line or a solid boundary line? And then you have to make a decision, am I going to shade above or below? Okay? All right, I'm going to give you guys some time to work. Make sure you're talking it through with your groups. Go ahead. Okay, so on A, what's my y-intercept? Guys, talk to me. Talk to me. 5. Okay, my y-intercept's 5. So there's my y-intercept. What is my slope? 1. So up 1 over 1. Put my points on here. I hate this stylus. Okay. All right. So now we have a couple decisions to make. Is this a dotted or a solid line? Dotted because it's not equal to, right? So I'm going to put dotted or dashed, whatever. Put that in there. Okay, so there's my dashed line. And then tell me, does this say y is bigger or smaller?
Bigger.
Y is bigger. So where is bigger on the graph? Up. Okay, let me give you a warning. Okay? Let me give you a warning. Okay? You have to make sure, if you are going to use greater than above, less than below, that y is by itself. Okay? An alternative method of testing. Okay? An alternative method of testing if you do not have y by itself. So say you are given an inequality in standard form where y is not by itself. You would not be able to just say greater than's above, less than's below. Okay? So an alternative way of testing is to test an ordered pair. Okay? What is going to always be the easiest ordered pair to test with? Even easier than 1, 1. 0, 0, right? So let's test with the origin, okay? So usually or always, if y is by itself, you can go greater than above, less than below. If not, you can always pick an ordered pair. Generally, the ordered pair we're going to test is 0, 0. Okay? Plug in that ordered pair. So plug it in. Y is 0. X is 0. Okay? And then check, is it true? So on the left I have 0. On the right I have 5. Is 0 greater than 5? No, it's not. So that's out. So that means my ordered pair does not work. So I shade the other side of the line. Okay? So let's try that. Let's try that on B. Okay? Just for kicks. So I have positive 1 for my slope. Negative 1/2 for my, I'm all kinds of screwed up. Let me start over. I have positive 1 for my y-intercept, so that goes on my y-axis. I have a negative 1/2 for my slope, so that's down 1 over 2. Down 1 over 2. Can also go up 1, left 2, up 1, left 2. Okay. Am I going to have a solid line or a dotted line? Solid because it's equal to, so go ahead and put your solid line through it. Okay. And then say y wasn't by itself and I want to test an ordered pair. So let's test the ordered pair 0, 0. Okay. So if I plug a 0 in for y, is less than or equal to negative 1/2 times 0 plus 1. So negative 1/2 times 0 is 0. So I have 0 is less than or equal to 1. Is 0 less than or equal to 1? Yes, so that tells me I need to shade the portion that point is in. Okay? So I'm showing you this thinking that you are not usually going to use this. I will tell you that most of the time in this class, you will be given these functions with y by itself. Okay? In which case, I can just come up here and say, okay, y is by itself. That's y is less than, right? So y is less than is going to tell you to shade down. Okay? So if y is by itself, it's super simple. If y is not by itself, that's when you got to test an ordered pair. Okay? All right, let's look at C. So my y-intercept on C is -5. So I'm going to put my dot at -5. My slope is -1, so that's down 1 over 1. Okay, dotted or solid line. Solid, because it's equal to. Okay, and then it says y is by itself, right? And it says y is bigger, so I'm going to shade up above. Okay, comfort level of how you're feeling right now. 3, 2, 1, 0. Three, two, 1, 0. How are we feeling? Okay, good. Let's go to the back. Okay, I'm going to look at one of these special cases with you, and then I'm going to have you guys do the rest, okay? So what happens if I don't have x and y? If you remember from our special case lines, okay, remember that it's always opposite the axis, right? You remember x equals a number and y equals a number lines? Yeah. All right, everybody show me the x-axis with your arm. She fooled you. The x-axis. I didn't say an x equals line. The x-axis.
Sorry.
Oh, I thought you were trying to trick them. Okay, x-axis is right here, right? So an x equals line goes opposite. So an x equals line is going to go vertical, right? Now everybody show me the y-axis with your arm.
Oh, y? Okay.
Axis, right? Y-axis is up and down. So we go opposite the axis for a y equals line.
There we go.
Okay? All right, so we have y equals line here, right? Y equals 4. So find 4 on the y-axis. Do you have a question?
No, I want to answer it because I know this.
Oh, just hold on to it. Let me teach. Okay, so y equals 4. So let's go up here to 4 on the y-axis. And then we're going to go opposite the axis. So the axis is up and down. My line's going to go left and right. Is it dotted or solid?
Dotted.
Dotted. Okay, and then that says y is smaller, so where am I going? Down. Okay, all right, pull over to 9 really quick. Whoa, what just happened? Okay, and let's look at x. Okay, so find 3 on the x-axis. That'd be over here, right? We want to go opposite the axis. The x-axis is left and right. So my line's going to go up and down. Is it dotted or solid? Dotted. And this is now the one time in all of linear inequalities that you cannot go up and down.
So it's like you don't shade it.
That is not true. Okay? This is the one time that we can't go up and down. So this says x is bigger. So just think about where are the bigger x values? To the right. So I'm going to shade right and left. Okay? All right, you guys go ahead and do those last four four remaining problems, and then we'll go over the word problem together. So 8, 13, 14, 15. Go ahead with those four with your groups. Go ahead. Let's go ahead and go over these, okay? So y equals -1. That's -1 on the y-axis, a horizontal line opposite the y-axis. It is a dotted line. It says y is greater, so I'm going up above. Any questions on 8? Okay, number 13. Y-intercept is 1, right here in the middle. Slope is 3, so up 3 over 1. I can also go down 3, left 1. It is a dotted boundary line because it's not equal to up here on the inequality sign. And then this says y is less, so I'm going down below. Any questions on 13? Okay, whoa, here's 14. Okay, I have a y-intercept of 1, so 1 on the y-axis. A slope of -1, so that's down 1 over 1, so that's why I go down 1 over 1. Equal sign on the inequality sign, so it is a solid line. And then this says y is greater, so I'm shading up above. Any questions there? Okay, and then last but not least, number 15. Did you notice number 15 was not y by itself? Okay, so we practiced using standard form. So you can do this problem one of two ways. You could graph it in standard form and test with an ordered pair. Or you could get y by itself and graph it just like you did the other ones. Okay? So if you did standard form, remember that's cover up. So I would cover up the y term and get x is 2. So that's 2 on the x-axis right here. I would cover up the x term and get y equals -2. So that's -2 on the y-axis here. It is a dotted line, and then I would have to test with an ordered pair. So test with the ordered pair 0, 0. So 0 minus 0 is smaller than 2. Since that ordered pair works out, that's the side that I shade. Okay? Alternatively, I want to show you this. So alternatively, I could take x minus y is less than 2 and solve for y. Ooh, that's kind of hard to see, isn't it? So I have x minus y is less than 2. Okay? So if I solve for y, I would have to subtract x. So I have -y is less than 2 minus x. I divide by the -1 that's in front of y on every piece. And remember, getting dividing by a negative makes me flip my inequality sign. So I have y is greater than now, right? I flip my inequality sign. 2 divided by -2 is -2. 2 divided by -1 is -2. And then -x divided by -1 is plus x. Okay? At that point, you know you have your y-intercept of -2, which is the same y-intercept this one had, right? A slope of +1, so up 1 over 1. You're going to get the same exact boundary line, right? Regardless of how I graph it, I'm going to get the same exact boundary line. We can see from this sign that it is not equal to, so it's a dotted line. And we can also see y is greater than, so we shade above. So you just have to decide what you are most comfortable with, okay? I want to give you options, but I want you to pick an option and run with it, okay? If you always want to get y by itself so you never have to test ordered pairs, then do that. Always get y by itself, never test an ordered pair. Just go based on the inequality sign. If you're comfortable flipping back and forth between standard form and slope-intercept form, then you can just do it as given, okay? Just know that if it's not slope-intercept form, you got to test an ordered pair. Questions? Okay, rest of the time is yours for prep.